Hello guys and welcome to another lesson of Mossy Maths with me, Tom Moss, and today we're going through the fourth lesson on the topic of coordinate geometry. And we're going through something called sketching cubics. Now a cubic is where we have a function with an order of 3, and what this means is that we have a power of x that has a maximum value of 3. A quadratic is where we have a power of 2. And I've done some videos on that, so if you haven't seen that already, it might be worth going back to those lessons, because this is sort of an extension to quadratics. There's going to be 4 key examples we have to learn. In particular, these two have to be learned. Just the shape of these is needed, but we need to know the exact curve of y equals x cubed and y equals minus x cubed. With these, it's more like just the shape, which we need to remember when answering questions. So, let's focus on this one. Y equals x cubed. So what happens is it slopes up towards the origin and then slopes back out again in this shape. We have to learn this. This is the standard graph of y equals x cubed. Now with y equals minus x cubed, this is the same thing, but it's the negative version. So when we have the line in the positive quadrant here, we have it in the negative quadrant here. When we have it in the left here, we have it on the right there. So it's effectively just reflected in the y-axis. So, now let's focus on answering this question. And when we do this, these graphs will become more relevant. So, it says sketch the graph of f of x equals x multiplied by x minus 1 multiplied by 2x plus 1. So what we do is at first we have to make this function equal 0. In doing this, we can then make each part of the function equal to 0 to find our roots. And by roots, I mean where it's going to cross the x-axis, which will enable us to then think about sketching the graph. So if we make this x equals 0, then that's a solution within itself. X is 0. If we make the x minus 1 equals 0, then we get x is 1, just moving the minus 1 across. And there's our second solution. Then if we make the 2x plus 1 equals 0, then we get x equals minus 1 divided by 2 minus a half. And there's our final solution. The next thing we do is we draw out the graph which we're going to sketch. Here we're going to need to know the Y-intercept as well, because that's a key part of the graph and they will expect you to label that in the exam. Well, the Y-intercept is the same as when x is 0. If we have no displacement on the x-axis, where x is 0, that's the same as the y-axis. Therefore, if we substitute x is 0 into this function, we will get the y value. 0 multiplied by all of this is just going to be 0. Anything times 0 is 0. So we're just going to get a y-intercept at 0. We've got roots of minus a half, 0 and 1. So they're the points it's going to cross the x-axis. Now this is where these graphs come into play. Because we need to see the general shape of the graph, and that's what we have to know before we can draw it. If it's a positive x cubed, if we have a coefficient of x cubed that's positive, it will go up, then it will bounce down, and then it will bounce back up again like this. If we have a negative coefficient of x cubed, then it will go down, bounce up, and then bounce back down again. So these are the general shapes we need to know about. So we now need to consider this function here. Is it positive or is it negative, the coefficient of x cubed? Well, if we do x times 2x, we get 2x cubed. And 2x cubed is positive because we don't have any negative coefficients of x. So if we get positive 2x cubed, then it's going to look like this graph. This is what the positive coefficients of x cubed look like. So it's got to go up, bounce down, then bounce back up. So it's going to go up through here, then it's got to bounce down to get to this point, and then it's going to bounce back up again to go through the final point, where x is 1. So, that's part A. Hopefully you followed exactly what we've done there. We've simply made the function equal 0, found the x values, which are the roots, where it crosses the x-axis, substituted in x is 0 to get our y-intercept, which in this case was 0 as well. And then we've drawn out the graph, finding out that if we expand this, we get a positive coefficient of x cubed, and therefore it's going to take this general shape here. Now let's focus on part B. Sketch g of x equals x minus 3 squared times x plus 1. Okay, so we make each bracket equal 0. If we make the x minus 3 equals 0, then we solve this to get x equals 3. And I've written times 2 in brackets. The reason I've done this is because we've got two brackets which say x minus 3. This is all squared, so it's x minus 3, x minus 3. So we're going to get two solutions which are x is 3. And that's important when we sketch the graph. I'll come on to that when we actually get to that part of the question. Now we make the x plus 1 equals 0. If we solve that, it's quite simple. X is minus 1. So our two solutions of x is minus 1 and x is 3. I should really say three solutions because it's a cubic equation. We've just got two solutions which are x is 3. Okay? Now we need to find the y-intercept by substituting in x is 0. Well, 0 minus 3 is minus 3. Then we square that, minus 3 squared, that's 9. And we're multiplying that by 0 plus 1, which is 1. So 9 multiplied by 0 plus 1, 9 multiplied by 1 is just 9. So that's our y-intercept. And now we can draw out the graph. X is minus 1, x is 3. There are 2 points, our two roots in this case. And our y-intercept is 9, which could be somewhere around there. Now, remember in the exam, with this question as well, we have to label the points. We have to label each root and the y-intercept. It's very important that you do label it. I haven't here because I don't have the space, but in the exam, have to remember it's important we label all of the coordinates of the points of intersection of the curve. Otherwise you won't get full marks. And the general shape has to be correct. You have to learn these general shapes here. And you should know about y equals x cubed and y equals minus x cubed as standard cubic functions. So with this, we've got a y-intercept of 9, and it crosses at x is minus 1 and x is 3. The next thing to do is to find what the coefficient of x cubed will be when we expand the function. So we're going to get x. Now if this is squared, we're going to multiply it by another x, that's x squared. Then we're multiplying it by this x, that's x cubed. X times x times x, x cubed. And we don't have a negative coefficient of x inside any of the brackets, so it's all positive. Therefore, 3 positives multiplied together is going to give us a positive function, positive coefficient of x cubed. So it's going to look like this again. So we've got to think it's going to go up through this point, then it's going to go down, and as all cubics do, it will go back up. The reason for this here is because we have two roots which are the same. We've got two roots at x is minus 3. As a result, the graph will actually bounce off that root. It will touch it and then reflect off it, like here. So if you have two roots that are the same, then this is what happens when you sketch the graph. Okay, so now let's do part C. Sketch h of x equals 2 minus x all cubed, making it equal to 0. We get x is 2. Quite simple, just move the minus x across to become positive. And we've got 3 times this root. So this is going to be more difficult to draw. Straight away we can see that. Then we substitute in x is 0 to give us our y-intercept. If x is 0, then 2 minus x, 2 minus 0 is 2. And then we cube it. 2 cubed is 8. Okay? It's quite straightforward. 2 minus 0 is 2, and this is cubed. 2 cubed is 8. So, the final thing to do again is to sketch this. Now we've only got one root, which is around there. And again, it doesn't matter exactly where you draw the root. Our y-intercept is 8. we just need to label this as 8, and this is the point 20. 0, 8, 2, 0. Remember to label them in the exam. Now we need to see what the general shape's going to be. Well, we've got minus x and we're cubing it. Well, minus x times minus x times minus x is going to give us minus x cubed. Because if we square a negative, we get a positive, but if we cube it, we get a negative. If the power is an odd number, then we're going to get a negative coefficient, which in this case is going to be minus x cubed. Therefore, we're now looking at this general shape. It's got to go down, back up, and back down again. So, now we've got to consider how we're going to draw this. Well, it's going to look something like this. Okay, I could have done that neater, but there we go. It's going to look like this shape. And it's weird because you expect this to go up and then go back down again like here. But this is slightly different, and I'll explain why that's the case. Here we've got 3 roots which are the same. Here we had 2 that were the same, and if 2 are the same, then it reflects off that point like here. It touches it and then reflects off it. But if we have 3 roots which are the same, in this case x is 2, then it actually just flattens out at that root. The graph briefly levels out and then continues on its course downwards. So we sort of skip out this bounce back upwards and replace it with a flat area of the graph because we have 3 roots. So if you've got 3 roots, it will look like this. If you've got 2 of the same root, then it will just reflect. So that's the graph that we get. And there's our answer to the third question. We've sketched all the graphs. Okay guys, so hopefully you followed that video okay. In the next video we'll be extending our understanding of coordinate geometry and moving on to the latter stages of this topic. I hope you understood everything we did. If you don't, then please feel free to put a comment below and I'll get back to you as soon as I can. So thanks a lot guys, and I'll see you in lesson 5 on coordinate geometry.